the reason it can be done, especially direct variation, can be done in an Algebra 1 class is because it basically turns out to be a y equals mx plus b type of thing. Okay, think about what that is. That's a line with a constant slope. All right, so something is varying directly with it. All right, the main thing is that you need to know that they're pretty much opposites of each other. Okay, so I'm gonna give you two little formulas that will work really nice. All right, if we've got something that varies directly, all right, I can write the equation y equals kx. All right, and then depending on the story problem, depending on what they give me, I can figure out what that k is, and then I can write the equation. All right, but that's y equals mx plus b. That's y equals k. It doesn't matter what my variable is. A direct variation is going to be linear in nature. Okay, now when something is inverse variation, if I've got inverse variation going on, all right, think of our inverse functions, kind of. All right, we've done inverse functions, we calculated inverse functions, that kind of thing. All right, instead of multiplying by k, we're going to have division involved. So we're going to have a y equals, my k is going to be on top, and then I'll have my x on the bottom. Okay, so if they write a story problem, depending on how they word it and how they phrase it, you should be able to write some type of an equation with a k, because you don't know what that k is. And then hopefully they're going to give you all the other variables, values for those other variables, and then you're going to be able to solve for k and then write an overall equation that represents the relationship between the things. Okay, so these are your two main things. When it varies directly, we're going to do it multiplication. When it is inverse, we're going to show it in the denominator, dividing it out. Okay, so now let's do a couple of examples here. Let's suppose I've got something that says, suppose A varies directly with X and inversely with the square of R. Also suppose A equals 16 when X equals 8 and R equals 4. Give an equation relating A with X and R. So yeah, it's really wordy. We got to write all that out before we can start. Okay, so the first part of the problem is going to tell you how to set up your equation that's got a k in it so that you can then plug the values in and find your k. All right, our ultimate goal overall is to write a final equation that relates A and B, or A, sorry, not A and B, A with X and R. All right, so what I'm going to do up here, it says suppose A varies, all right, directly with X and inversely with the square of R. Okay, so there's our two pieces of information and how we're going to write our equation. All right, so A is varying with those. So I'm going to start out with an A equals, okay, because A is varying directly with these things, inversely with something else. All right, now, since this one has both direct and inverse, I might as well go ahead and get a division in there because I'm going to have both. All right, my K is going to go on the top. All right, now when it varies directly, I need to be multiplying it by my K. So A varies directly with X, so I'm just going to have to do times X in the top, because when it's directly, it's multiplication. Inversely with the square of R, so when it varies inversely, it's going to be divided by, the K will be on the top, it'll be in the bottom, so the square of R, so R squared. Okay, did that make sense? Might as well, if you've got both, might as well go ahead and put k over in a great big line, figure out what goes on the top, figure out what goes on the bottom. All right, now once you have that, then you go through the rest of the problem and find out what all the variables are, because they should tell you, at this point, they should tell you a and x and r, all right, which they do. They tell me a is 16, they tell me x is 8, and they give me r is 4. So then I can plug all those values in and figure out what k is. All right, so let's not make a mistake here. We'll plug in 16 in for a. We'll plug in 8 in for the x. So I've got a k times an 8 on the top. And then r squared, r is 4. So r squared on the bottom. Okay, so I'm going to keep going here. 16 equals, I'm going to go ahead and write 8k on the top. 4 squared on the bottom is 16. Multiply both sides by 16. Multiply both sides by 16 because it's just an equation. I'm just trying to solve here. 256, I think, is equal to 8k. And then 256 divided by 8. Hopefully it comes out even. It does. K is going to be 32. Okay, now I know my k. Now, the thing is, I'm not done. Yes, I had to find k. It didn't tell me to find k. What did it tell me to do? It says give an equation that is relating a with this. All right, so I've already wrote the equation. My equation is right here. All right, but now I know what k is, so I'm going to take k and I'm going to put it back in there. Okay, so then my equation is a equals 32x over r squared. So then really that's my final answer. Seems simple enough? Kind of, sort of. You're like, maybe. When it says directly, you're going to multiply it by the k. When it says inversely, you're going to divide it by the k. Okay? Alright, so I'm going to do one more and then I'm going to let you try it. Okay? So let's write out another one. You try it. Alright, let's suppose W varies inversely with C and directly with twice X. Also suppose that W equals 20 when C equals 2 and X equals 4. Give an equation relating W with C and X. I'll give you a few minutes and I'll let you try that. It says, suppose W varies inversely with C and directly with twice X. Alright, so we got this W thing going and it is doing what? It's varying inversely with C, which means that's going to be on the bottom of my K, directly with twice X. Alright, so every time I'm going to start, I'm going to do my W, because that is what's varying with the other letters, is equal to, I'm going to go ahead and put, since I know I see inverse and directly, I'm going to go ahead and put my K in, whoops, that should be black, and then I'm going to have my horizontal line. If it is directly, it's going to go on top. If it's inversely, it's going to go on the bottom. So I'm going to have C on the bottom, and then directly with twice X means 2 times X. Alright, so then I'm going to have a 2x right there. Okay, so did we have the equation right? Okay, because that's your start equation. Okay, then you're just going to go through and now put in all of our variables. Okay, so W is 20. We got a K. 2 times X, X is 4, so 2 times 4. And C is 2. Alright, variety of ways that you can solve this equation. Alright, I got a 2 on the top and 2 on the bottom. I'm just going to cross them out. Okay, then I'll have down to a 20 equals 4K. Divide both sides by 4, so K is 5. How many people got K 5? Okay, K with 5. Okay, all right. And then, now I know my K value, and my goal is to write an equation. So I already worked at writing that equation up here, so I just have to take my K value and put it back in. So then my equation will be W is equal to a 5 times a 2x over a C. Okay, but can I clean it up a little bit? 5 times 2 is 10. So can I say W equals 10x over C? Cleans it up a little bit. If you've taken the SAT, you probably solved some direct variation, inverse variation problems. All right, as story problems, maybe not just plain numbers like this. They might have put it in the context of a story, but this was just more playing around with it, trying to get you to get the ideas. Okay, the main thing is directly inverse. If it's directly inverse, you multiply it by the K on the top. If it's inverse, put it on the bottom. You get that initial equation. Okay, you'll practice some on the worksheet. All right, now, next thing I want to do is, we know how to do systems of equations, either by elimination or by substitution. All right, but specifically, what they've been doing, or what I've been doing on the handout so far, has been just give you a system and then you solve it. All right, well, if you're given a story problem first, then you have to write the system before you can solve it. All right, so the system is going to be specifically pertaining to investments. So we're going to say system of equations, and then we're going to say investments. All right, and last block told me that due to our pandemic situation, they didn't even do these type story problems at all in Algebra 2. Okay, so now this may be your first exposure to it. Okay, all right, so again, the story problem can be written in a variety of different ways. So there's no way I could do an example of everything. So this is just one sample to kind of get you the idea here of what we're doing. Okay, so let's suppose Jane has $80,000 to invest. She puts some of the money in a savings account, paying 7% interest. And the rest in an account paying 8.4% interest. After 1 year, the combined balance is $86,300. The question is, how much did Jane invest in each account? Very long story problem when we got to write the darn thing out. Now there's some key parts to this. All right. She's got a total of $80,000. Okay, that's how much money she has to start with. She's going to put them into two different accounts. All right, so one account pays the 7% interest. The other account pays the 8.4% interest. So she's going to take that $80,000 and she's going to divide it up. All right, could be half and half. She could put 60,000 in one, 20,000 in the next, 40,000 in one, 40,000 in the other one. All right, that's what we're trying to figure out. How much did she put in each of the two accounts? All right, now if we're going to do a system of equation, we have to do two equations. All right, one of them is going to deal with just the amount of money she has total. Okay, so that we don't have to actually define our variables here. Let's say the amount of money that she puts in this account we say is X, and the amount she puts in this account we say is y. Okay, so because we're going to have, we got two different values here, we'll have two different numbers. All right, so however much money she put in that 7% interest account is x. The amount she put in the 8.4% account is y. And those two numbers have to add up to the $80,000. Okay, so the first equation is always going to be simple because it's going to be x plus y equals the total amount. Okay, now this is an interest problem. Okay, if I want to know how much interest this amount of money earns, I multiply it by 0.07. If I want to know how much interest this earns, I multiply it by 0.084. Okay, and then it says after 1 year the combined balance is $86,300. If the balance in both those counts is this much money, how much money did she get in interest? $6,300, right? Okay, because she started with $80,000. Now the combined balance is $86,300. So $86,300 minus the $80,000 means that she had $6,300 in interest. Okay, so that's just something that you're going to kind of do in your head. All right, I wrote it down though because it's the first time we've done it here. So my second equation deals with the interest. All right, so the amount of interest for the first one would be 0.07. 0.07 times x would give me that amount of interest from that account. And then if I change the 8.4% to a decimal, I'd have 0.084y. That's going to tell me the amount of interest that was earned there, and that's going to equal what? The total amount of interest that was earned, which was $6,300. So see, now you have a system of equation to solve. Okay? Typically, people solve this by substitution. All right. However, I tried that last block and they all looked at me like, no, we don't want to use substitution. We like elimination. All right. It really doesn't matter. If you like substitution, solve it with substitution. If you like elimination, solve it with elimination. It's going to be kind of a lot of work no matter which way you go. All right. Do we have a preference in here? Substitution. Because it makes sense, right? Because this equation is really nice to solve for x or y, right? Yeah, last block did not see that. Okay. All right, we'll do substitution. All right, so I'm going to draw a little line here. All right, so that means I'll even line out all the little steps here. Step one, if I do solve one of those for, let's solve for x. So x plus y equals 80,000. I'm going to show all my steps. I'm going to solve for x, which means x is going to be 80,000 minus y. Okay, and then step two means I'm going to substitute that back into the second equation. So my second equation is 0.07x plus 0.084y equals 6,300. All right, it's going to get substituted back in for that x right there. So 0.07 times 80,000 minus y plus 0.084y equals 6,300. And then at this point you are going to, I'm pulling out a calculator because I'm not going to do 0.07 times 80,000. Okay, so I got 5,600 minus 0.07y plus 0.084y. I'm counting on you guys to catch me making any silly mistakes. Then we got some like terms over here, right? These two things are like terms. So negative 0.07 plus 0.084. And I have too many decimals on my calculator right now. Plus 0.084. Okay, so I got a... Did I really do that? I got a 0.014y. Are you guys checking me? And then I'm going to subtract 5,600 from both sides. And I get 700. And then now I can divide by 0.014. So I get 50,000. So that means 50,000 was invested at 8.4%. All right, now can you figure out how much was invested at 7? Plug it back in, subtract, right? I had $80,000. 50,000 is invested in one account, so that means 30,000 is invested in the other one. All right, you probably need to summarize your answer here somehow. The 50,000 was invested at, that's Y. My Y was the 8.4%, and then that means that the 30,000 was invested at the 7% as a final answer there.